Hello friends, this is Nagaraj SK here and welcome back once again to this series of learning design and analysis of algorithms. So in the previous session we saw that how to implement the insertion sort algorithm using decrease and conquer technique, and how to sort the given list of items or the given array in an ascending order or in an descending order, right? So in this session we'll move to the next experiment, that is find a minimum cost spanning tree of a given undirected path using a Prim's algorithm. So this is our next experiment. So first we have to understand what is Prim's algorithm, how it works, then we can go for coding, right? So I hope everyone knows here what is minimum cost spanning tree is. Minimum cost spanning tree is nothing but we have to traverse all the vertices or all the nodes of the given graph, and we should traverse across all the nodes of the given graph, but with minimum cost, with minimum weights of the edges of the spanning tree or edges of the given graph, given tree. So that is what minimum cost spanning tree is. It should cost us less to traverse all the vertices, all the nodes of the given graph, but while traversing it should not form any cycles. So we'll see, that is about a minimum cost spanning tree. So we'll see how exactly this Prim's algorithm helps us to implement this minimum cost spanning tree, right? So we will be given an undirected path, so we have to make use of that, and we have to find the minimum cost spanning tree from the given graph using Prim's algorithm. So what is Prim's algorithm, right? Prim's algorithm is used to find the minimum spanning tree from a graph. First of all, so Prim's algorithm finds the subset of edges that includes every vertex of the graph, such that the sum of the weights of the edges can be minimized. Then it starts, this algorithm, Prim's algorithm starts with the single node and explore all the adjacent nodes with all the connecting edges at every step. The edges with the minimal weights causing no cycles in the graph got selected. So this is about Prim's algorithm. So I'll be writing here the steps of Prim's algorithm. So let me write those steps and show you how exactly this Prim's algorithm works. So hold a minute. So these are the steps of this Prim's algorithm. So here it is, Prim's algorithm. Prim's algorithm. So step 1 says that select a starting vertex. We have to select a starting vertex first. That is Prim's first step. Then he says that repeat step 3 and 4 until there are fringe vertices. That is nothing but we have to repeat step 3 and 4 until the end of the vertices, until the edge of the vertices. That is fringe vertices. So Step step 3 says that select an edge E connecting the tree vertex and fringe vertex that has a minimum weight. That is, we have to select an edge which is having less weight among all the weights which are present in the graph, in the tree. So in such a way that we have to select two vertices which are connected by an edge which is having less weight. That is what step 3 says. And step 4 says that add the selected edge and the vertex to the minimum spanning tree T. Add the selected edge and the vertex to the minimum spanning tree T. So once you do this step 3 and 4, you have to repeat again and again until there are fringe vertices. So once you done with this, we will be getting the minimum cost spanning tree for the given graph, and we have to exit it. Then we will be getting the minimum cost spanning tree. So this is how the Prim's algorithm works. So let me take here one example and show you how exactly it works. Suppose this is, if you consider as an example, we have to apply for this given graph the Prim's algorithm. Whatever Prim's algorithm is there, we have to, if you apply for that, how the minimum cost spanning tree we will get, right? So if I apply this, we'll be getting minimum spanning tree. So let me begin with the first step. So select a starting vertex. In the first step he's saying that select a starting vertex. So if I select this b as a starting vertex, then from that vertex I have to check in the next step. What is telling? Repeat step 3 and 4 until there are fringe vertices. So what is step 3 saying? Select an edge e connecting the tree vertex and fringe vertex that has minimum weight. So as in the step 1 I have considered this b as my starting vertex. I have to check which all the nodes are connected, to that vertex. One is connected to this edge which is having 4 weight, and one more edge which is connected to this starting vertex p, that is c, this edge which is having C node which is having 10 as the weight. So among these two, which is the least, which is the minimum, so that we have to select. That means I have to consider the next vertex, this one, that is D. So BD is having minimum weight, that we need to select the edge. That is the third step, that is select an edge e connecting the tree vertex and fringe vertex that has minimum weight. So this is the minimum weight if you consider this b as starting vertex. So this will be the first edge, that is b to d, that is having 4. Then again you check which is the edge which is having least or minimum weight from d and b to some other, these already selected, so some other we need to check for c, for e and a. So this edge is selected now, right? B to D. Then from this B and D, which all edges are connected? This B to C is there, that is having 10 weight. Then D to C is there, that is having 2 weight. Then D to E is there, that is having weight 1. So among these three, which is the least one? This is the least one. So this we need to select. That is from D to E, weight is 1. So the next edge will come in the spanning tree, that is D to E. That means in the minimum spanning tree we visited this E vertex also. So now we are having 3 here, that is 3 vertices B, D and E in the minimum spanning tree. Then from these 3 B, D and E, from these 3 which all are the edges are going to some other vertices and which are having less weight, that we need to identify. So this is over, this is over, and we are having here B to C is 10, D to C is 2, then E to C is 6. Which is the least among these three? 10 to 6. This 2 is the least one, right? This 2 is the least one, that we need to select. From B to D we are traversing, again D to E we are traversing, again D to C we are traversing, because which is having less weight, less cost to traverse from D to C. If you go through, even though we can travel through B, we can travel through E, but it will be costing us more. Here if you go through D to E, one is the cost, that is weight is the 1. Then from E to C again 6 weight is there, that is value is 6. 1 plus 7, 1 plus 6 is 7. So it is more than 2, less than 10. But the least one we need to select. So that is our aim, that is our goal. So we need to select D to C, and which is this edge is having weight as 2. Again, all the 4 nodes we visited, only one remaining is A. So which is the only one edge which is connecting to E, which is connecting to A. So which is that from C to A, which is having weight as 3. There is no other edges are connecting to A. So by default we have to select this edge which is having weight as 3. So our graph looks like this: B, D, E, then D to C, then C to A. This is our minimum spanning tree. So let me draw that minimum spanning tree here, then it will be clear for you people. So hold a minute. So once you applied this Prim's algorithm for this given graph, then you'll be getting a minimum spanning tree like this. So here we are selecting B as the starting vertex, and from that, which is the edge connecting to other fringe vertex which is having least weight, so that is 4. So that is D vertex. From D again, from B again, which is connected least which is the edge having least value, that is D to E, we traverse to E. Then again from D to C we traverse C, which is having less weight. And from C to A, which is having again less, only one edge is traversing to A from C through C. So that edge we are selecting, and we are forming the minimum spanning tree, that is minimum cost spanning tree. This is how the Prim's algorithm works. So this is all about the introduction or working of Prim's algorithm. So let me code for this, and will execute the program and understand that how we can code for this particular task, right? So we'll move to the coding part, then I'll show you that how to write the code for that. So I'll begin with this hash include stdio.h as the header file, that is for input output operations. So I would like to define here some standard constants with the help of hash define function. Hash define size is 20. I'm just considering as 20. Then one more constant I'm going to define, that is hash define, then infinity value we are going to define, that is consider 32767. So these are the two constants I'm declaring here, and after that I'm going to write the Prim's method here, Prim's function, that is void prim. So I'm going to define here one function by the name prim. So prim int, it is taking some arguments like an array, that is g, that is graph, then size, comma int nodes, number of nodes. So here I'm going to consider some of the local variables like select size, comma I, comma j, comma k. These are the three variables for loops. Then int min as the minimum weight for the minimum distance, right? So next that is min, what I'll take min underscore distance, minimum distance. Then vertex 1 comma vertex 2, that is starting vertex and fringe vertex. then total. Initially it is 0. The cost of traversing from one node to another node is initially 0. So for I equal to for I equal to 0, I less than n, that is nodes, then I plus plus, right? Then among these nodes, what I have to select I equal to 0. Then we have to print the minimum spanning tree. Printf slash n, the minimum spanning tree is so slash n, then so initially select array is equal to initial array, that is select is equal to 1, so that is select of 0, that is first value of this array is 1. Then for k equal to 1, then k less than nodes, then k plus plus. So we have to find the minimum distance between the two nodes. So min distance is equal to initially infinity. Then we have to traverse all the nodes. So once we select initial node, from that node which is the node connecting and which is having less weight, that we need to identify, so that we need to select. So we have to check all the nodes which are present in the graph. So for that I equal to 0, then I less than nodes, then I plus plus, until it finds the minimum weights edge. We need to traverse, we need to go on searching. So for that we need to go on verifying each and every node which is having which are the two nodes are having a least value edge. So j equal to 0, then j less than nodes, then j plus plus. If graph of I, that is g of I and j and select of I and not select of I, not select of j, or not select of I and select of j and select of j. If either one of these two cases are true, then what we have to do here is we have to check one more condition, that is if graph of I, that is g of I and j, whether it is less than min distance or not. That condition we need to check, and if it is true, then we have to set min distance is equal to g of ij. That means which is the least weight which is present, which is connecting two nodes, two vertices. So we need to set v1 equal to I and v2 is equal to j. Then once we found with that least weight edge, we need to print that. So for that I have to use printf statement here, that is edge percentage d comma percentage d and weight of that edge is, that is weight equal to percentage d. Then which are the two vertices which are connected by this edge, so that is v1 and v2, comma what is the distance between them, that is min distance, and select that particular edge and assign it to the array, that is select of v1. Select of v1 is equal to select of v2, that is equal to 1. Then once we're done with that, we have to find the total cost of that particular spanning tree. So total, initially total was 0, so now total is equal to total plus minimum distance. Then print the total value, which is, that is the cost of the spanning tree. So printf /n total path length is percentage d comma the total, which is having the total value of the minimum cost spanning tree. So in main method we have to call this particular method, that is prim method. So here I'm going to consider some of the variables, like that is array g of size constant, whatever the constant value we have defined globally. So one more variable, that is nodes. Then int v1 comma v2 comma length, then I comma j comma n. Then ask the user to enter the number of nodes he is going to use to draw the graph. So printf ask user to enter the number of nodes. So enter the number of nodes, enter the number of nodes in the graph. Scanf read that number of nodes in the graph. So with the help of scanf %d, then ampersand nodes, ampersand nodes. Then printf, one more printf is used to enter the number of edges which are required to connect all the vertices, all the nodes. So for that again we need to ask user to enter the number of edges, number of edges in graph. So read the value of the number of edges with the help of scanf statement. Then percentage d comma ampersand n, that is the address of the variable n. Once we got number of nodes and number of edges, then we need to ask user to enter the weights for each edge. So printf, so enter the edges and weights. Then read the values of edges with the help of for loop, that is for I equal to 0, then I less than n, I plus plus. So for that printf slash n enter the edge by v1 and v2 is, then read that value, that is with the help of scanf statement, scanf percentage d for v1 and percentage d for v2. So read the value of v1 and v2 with the help of address operator, that is location of v1 and v2. Then one more printf statement is for entering the weight, that is printf slash n enter corresponding weight, enter corresponding weight, enter corresponding weight. Then read the value of that weight with help of scanf statement. So scanf percentage d, then ampersand length. So the array, that is G graph v1 and v2 will be initialized by G of v2 and v1, that is equal to the length of the given graph. So once we are done with this, we need to call, once we are having the number of edges, number of nodes and the weights for each of those edges, we need to call prim's algorithm to get the minimum cost spanning tree. So let me call here that prim's method, that is prim's function. So prim, and as we have defined it, it is taking two parameters, that is an array G and number of nodes, that is nodes. So once we called here, it will be finding the minimum cost spanning tree for the given values here. So this is all about the coding part here. So let me run this code and check whether it gives the proper output or not. So let me run here. So click on the run button. Okay, there is an error, so go and check that line number 22. Click on the line number 22, and for I equal to 0, okay, there is a semicolon missing. So I equal to 0, I less than nodes I plus plus, and check it once again and click on the run button. Yes, enter the number of nodes in the graph. So it's working fine. So now I have to pass the input and check whether it gives the proper output or not. Enter the number of nodes in the graph. So I would like to enter here 7 as the number of nodes. Then enter the number of edges in the graph. So I would like to enter 9 here. Then enter edge by v1 and v2. So that is 0 and 1, right? Then enter the corresponding weight for that is v1 and v2. So the weight I would like to enter here 27. Then there are 7 nodes, so we have to enter enter the nodes, that is v1 and v2, that is starting vertex and fringe vertex values, edges values. So the next vertexes are 1 and 2. Then enter corresponding weight for that. So I'll be entering here 16. Then enter the edge by v1 and v2. So again I'll be entering 2 3 2 3. Then the corresponding weight for that particular edge is 12. Then the nodes v1 and v2, that is 3 and 4, and weight is of 22. Then 4 and 5, then weight is 25. Then one more, that is from 0 to 5, weight is 6. Then there is one more edge, that is 1 to 6, the weight is of 14. Then 4 and 6, the weight is 24. And finally 3 and 6 edge, that is from third vertex to sixth vertex, there is an edge which is having weight as 18. So this is all my input data. So the minimum spanning tree is, and weight is, total path length is, okay. So it is giving something else. It is not giving the proper output. So let me check the code once again and rerun it once again. So just hold a minute. So check it once again. Click on the run button. Enter number of nodes in the path in the graph. So I would like to enter here 7 again. Then enter number of edges in graph, that is 9. So number of edge in the graph are 9. Then enter the edges and weight. So enter edge by v1 and v2, so that is 0 and 1. So the weight is 27. I would like to enter. Then enter the edge by v1 and v2 vertex, that is 1 and 2, right? So the weight I would like to enter is 16. Then enter the edge by v1 and v2, that is 2 and 3, 2 and 3, right? 2 and 3, I would like to enter 12. Then v1 and v2 I would like to enter, that is 3 4. From 3 to 4, third vertex to fourth vertex, the weight is 22. Then 4 and 5, from fourth vertex to fifth vertex, the edge is 25. Then from 0 to 5, the weight is 6. Then from 1 to 6, 1 to 6, the weight is 14. Then from 4 to 6, the weight is 24. Then from the vertices, from third vertex to sixth vertex, that is from third node to sixth node, the weight is 18. So hit the button enter, you will be getting the minimum spanning tree as below. That is the minimum spanning tree is, so here the minimum spanning tree is edge from 0 to 5, that is first node to fifth node, weight is 6. Then edge from 4 to 5, weight is 25. Then edge from 3 to 4, weight is 22. Then edge from 2 to 3 is weight is 12. Then edge 1 to 2 is weight is 16. Then then last one, that is 1 to 6 is weight is 14. The total path length is 95. This is how the Prim's algorithm works. So if you are having any doubts in this, please do ask your queries and let me know your queries, and definitely I'll be helping you out for your problems, for your questions. And thanks for watching.